Hello and welcome to the course of MSMP. In this lecture, we will be discussing about this is 24th lecture of 4th module, that is your machining chapter. In this lecture, we will be discussing about cutting fluids. The cutting fluids. What is cutting fluids? Cutting fluids are the lubricant or coolant that is used in time of cutting. So this is a general idea of cutting fluid. These cutting fluids have various purposes, and it has various material can be used as cutting fluid, and the application of cutting fluid can be different depending on all of these parameters. What will happen? The cutting fluid will have a great effect on the surface finish of the workpiece. That means the quality of the cut depends on the cutting fluid. So this is the importance of the cutting fluid. So in this lecture we will be seeing all about the cutting fluid. Now let's start our lecture by knowing the lecture objective. The lecture objective the lecture objective is to identify the need of cutting fluid in the metal cutting. What is the need of cutting fluid? That we will identify first. After knowing the necessity of the cutting fluid, we will move on to the different cutting fluid and methods by which this different cutting fluid can be applied to a body. So that we will see. So let's start with the definition. What is the definition of the cutting fluid? As we can write that the definition such as the cutting fluid are the fluids that used in the time of machining to lubricate and cool the chip tool interface. See here what is occurring here in the chip in the chip formation mechanism. What I have said that if this is the cutting tool, this is your cutting tool, then here chip will form, and chip will flow above the rake surface. The chip will flow above the rake surface at this interface where chip interact or chip touches, chip are in contact with the with the cutting tool. That position is known as secondary deformation zone or chip tool interface. So this chip tool interface is subjected to high rate of friction. Due to this high rate of friction, what will occur? The temperature of that position will increase. So that's why there is some very much difficult some very serious defects may occur in the case of cutting tool, and that will lead to wear out of the cutting tool. That means the tool life will be lesser if we do not use the cutting fluid. So what is the function of the cutting fluid? Cutting fluids are used to lubricate or cool the chip tool interface. So if we can lubricate, that means the friction at that chip tool interface will be reduced, and if the friction is reduced, that means the heat generation is also reduced. So as the heat generation and the friction both are reduced, that is done by what? That is done by only the cutting fluid. So whenever a cutting fluid is used in case of machining, that machining is known as wet machining. But there is some machining technique especially for the tool, for the ceramic tool material. So when the tool is ceramic, at that time what will occur? At that time we do not need any external cutting fluid to lubricate, because the friction at the chip tool interface, when we use a ceramic cutting tool, at that time the friction will be very less. So the heat generation is also will be less, and the ceramic materials can withstand high amount of heat. Due to all of this, the in case of ceramic, dry machining is dry machining is advised. Now let's see about the different type of cutting fluids. There are various types of cutting fluid. First is gaseous type, next is liquid type. The gaseous type cutting fluids are not widely used or discussed, so we will discuss only about the cutting fluid that is in liquid form. So in liquid form, the one of the greatest cutting fluid is water, next fatty oil, next mineral oil, cutting oil, and soluble oil. So whenever these are all the cutting fluid material, that is water, fatty oil, mineral oil, cutting oil, soluble oil, and these liquid type cutting fluid materials sometimes mixed together so to have a better result. That means the in some case the mixture of fatty oil and water is poured into the chip tool interface, and this pouring can be done by, or this application can be done by various methods that we will discuss on later on. So what is the requirement of cutting fluid? So can we say any material that this is a cutting fluid? No. For being a cutting fluid, a material or the liquid should have certain properties, and in this slide we will be discussing about that properties, that is requirement of cutting fluid. So cutting fluid should possess high specific heat, thermal conductivity, and heat of vaporization. So high specific heat, why high specific heat is needed? Because the cutting fluid, the main aim of the cutting fluid is to one of the main aim of the cutting fluid is to cool the chip tool interface. To cool any interface, we have to dissipate high amount of heat, and that high amount of heat will be dissipated only if that water or that your that coolant can receive or can absorb that much amount of heat. So to absorb much more amount of heat, the specific heat of the liquid should be higher. So that's why as the specific heat is higher, the heat absorption will be higher, thus the heat dissipation also will be higher. So that is the first reason. Secondly, thermal conductivity should be there. If there is no thermal conductivity, at that time what will happen? At that time, at the chip tool interface, the temperature will always rise, because if it absorbs, if because in that case that coolant will absorb the heat, and absorbing only, it is only absorbing but not transferring anywhere. That means there is no conduction occurring at that interface. At the contact, from the contact surface, heat will be added to the coolant that is in contact with the chip tool interface. The cooling effect won't be there if there is no thermal conductivity. So that's why thermal conductivity also should be higher, and this high heat of vaporization should be there, because if the liquid is vaporized while the application, when the application is done, means we add water to in any chip tool interface, and what will happen? All of the water is vaporized. If that will happen, that means the in that chip tool interface there is no lubricant or no cutting fluid. So that would lead us to a problem. So that's why what is needed, the heat of vaporization of those cutting fluid should be higher, and the application should be selected on the basis of known value of heat generation. That means for a specific specific workpiece and cutting tool combination, there is a known value of heat generation that is developed over the year by experimentation, and this known value should be compared with the values of the cutting fluid, and by that the specific the most suitable cutting fluid should be chosen for application. Next uh, point is that cutting fluid should not discolor the finished work surface. Cutting fluid may flow over the work surface, but it should not degrade or discolor the finished part. Next is, it should not carry any fairly mild smell. So the material cutting tool material should not carry any smell, because if there is any smell, that may be create and discomfort to the work environment, to the operator. So that's why the cutting fluid should not carry any smell. Next, during its use, it should not produce smoke or fog. That means its flash point should be high. So during the application there is heat, okay, and there is a high chance of smoke forming or smoke forming. That smoke forming and smoke forming shouldn't be here, should not be uh, in the case of the cutting fluid. And the flash point is the temperature at which the material ignite itself. So that flash point temperature should be very high. And next is, the material should not be toxic and should not create any skin disease, because skin irritation, because there is complete human interaction for operating the machine tools. So that's why the material should not be toxic and does not create any skin irritation. Next is, it should not flow easily. It should the cutting fluid should flow very easily and cover the entire cutting area. So it should it should flow very easily, and it should cover the entire cutting area. The process, it should lubricate, it should give good lubricating property. The cutting fluid should give good lubricating property. So these are the properties that should, or the requirement to be the cutting fluid. Now we will see the selection of the cutting fluid. That, as I am saying, that cutting fluid is selected on the basis of cutting tool material first. So cutting tool material means what is the material we are using for cutting. That if the cutting tool material is of very low hardness, or depending upon the what cutting tool material is using, we are using, the application of the cutting fluid is varied. Because for example, as I am saying earlier, that if we use ceramic cutting tool, the operation is dry machining or dry manufacturing, where no cutting tool is used. But in case of other machining process such as milling, drilling, by using your insert tool or HSS tool, at that time we just we put the cutting fluid, mainly soluble oil. So this combination HSS with soluble oil, your uh, carbide insert with synthetic oil. So this combination has been done, has been depend on the cutting tool material. So selection of the cutting tool, cutting fluid depends on the cutting tool material first. Secondly, the workpiece material, what workpiece we are machining, that depending on that the selection will be done. Third, type of machining operation, is it drilling, is it boring, is it your milling, or it is turning. Depending upon that, the type of machining operation, we can decide about the what cutting fluid we need. Viscosity, that viscosity of the cutting fluid or viscosity of that oil is a important factor. Machining condition, cost, color, smell and oiliness, these are all the important factor that should be considered while selecting the cutting fluid. Now, the cutting fluid can be applied in three ways. First one is mist cooling, second one is flood cooling, and third one is manual cooling. In case of mist cooling, what is given, the mist means small droplet, jet of small droplet. So whenever whenever the at that workpiece, at the chip tool interface, whenever we just sprinkle the water, sprinkle the coolant or sprinkle the cutting fluid, at that time what will be there, the mist will be generated, or small particle of that cutting fluid will be generated in the environment, that creates that improves the cutting condition. First, second is flood cooling. Flood cooling is a way where the cutting fluid is applied directly in the chip tool interface in the form of flood, and the cooling operation will take place. Next is manual cooling. Whenever the method of giving or method of applying the workpiece, at applying the chip tool interface, this cooling operation, these applications are very important. Now, what is the function? As I am discussing, that the main function of the cutting fluid is provide cooling, next to provide lubrication, and other than that, prolonged cutting tool life can be achieved by application of cutting fluid. That cutting fluid provides rust control, and it also resists the redundancy. So these are all about your cutting fluid. Thank you, hope you understand this lecture, and if you have any problem, you may ask in the live class. Thank you.